All right, good morning and welcome back. Today we're on lesson 6.2. As a reminder, if you want a copy of these notes, go into It's Learning, click on Resources in Chapter 6, and then at the top there's a PDF with this file in. You can either print it off or download it and edit it digitally, whatever you prefer. And also another reminder, just remember next week we will be back to our hybrid schedule. So if you are in the first half of the alphabet, you'll be at school Monday, Tuesday, second half on Wednesday and Thursday. The days you are at home, you'll need to sign into It's Learning, find these videos, and go ahead and follow along from home. So today we are going to continue talking about trig functions. So hopefully you remember we had our 6 trig functions. So the sine, cosine, and tangent. I'm guessing you were familiar with those 3 from before. Then remember cosecant pairs with sine, secant pairs up with cosine, and cotangent pairs up with tangent. Now when I say they pair up, remember they are the reciprocals. So sine, the reciprocal of sine is cosecant, reciprocal of cosine is secant, the reciprocal of tangent is cotangent, and vice versa. Okay, so now if we look at this picture, or this example here, it says find the exact value of the remaining trigonometric functions. Now as you'll recall, when we did it before, we had triangles. This time we don't have a triangle. We just need to go based on they gave us what sine is, and they gave us what cosine is. However, hopefully you remember, we don't have a picture, but we can still determine some things. We know SOHCAHTOA, so sine is opposite over hypotenuse. So if that's the case, we know that our opposite is 1, our hypotenuse is 2. Meanwhile, cosine is adjacent over hypotenuse, so that'd be A over H. Okay, so from here, this should give us enough information to solve the 4 remaining trigonometric functions. So if you wanted, you could draw a picture. We don't even really need to, though. We have what O is, we have what H is, we have what A is. Now we just need to figure them out, and then if there's any square roots on the denominator, we got to rationalize them. So if we look here, we've got tangent first. So tangent is TOA, O over A. So our O is 1. Our A is square root of 3. Now square root of 3 can't be on the bottom. We need to rationalize the denominator. We multiply that by square root of 3 over square root of 3. The reason I chose 3 is because that's what was already in the denominator. Okay, we multiply across the top, and we just get square root of 3. Across the bottom, we just get 3. And right there, that is our answer. Okay, so now the next one, cosecant. Remember, this is the reciprocal of sine. So instead of O over H, it is H over O, which this one's pretty easy. Instead of 1 over 2, it's just 2 over 1. If we reduce that, we get 2 as our answer here. Secant pairs up with cosine. Okay, so secant, instead of square root of 3 over 2, it becomes H over A, so it's going to become 2 over square root of 3. So from here, we need to multiply this by square root of 3, and we'll multiply by square root of 3. We go across the top, we get 2 square root of 3 over 3. Okay, and then our final one will be cotangent, and this one is the reciprocal of tangent. Okay, so we could deal with what we have right here, or we could deal with what we had at the beginning here. The other way we can think about it is it's A over O. So all of those ways will work. A is square root of 3. O is 1. So that is just the square root of 3 as our answer. Forgot to box that one. So there we go. We are done. Now, for our next one, same approach. This time, all it asks us to find is the value of tangent. So all we need to find here is tangent. The only difference you might notice is now I have a negative sign right here. We have not had negatives yet. So some of you might be wondering, does that go with 3? Does that go with the 5? Does it go with both? Well, here's the thing. It can't go with both, because if it went with both, negative divided by a negative, that's a positive. It would cancel out, okay? So either the top or the bottom. So this is O over H, and this one, cosine, is A over H. We're going to have to put that negative with our adjacent. We cannot have a negative hypotenuse because the hypotenuse is like our distance along the line. Now, some of you might be thinking, how can we have a negative adjacent side? And I'll show you. Technically, the distance or the length of the side is still positive, but it is in the negative direction. Okay, and I'll show you that more in a little bit. But one thing you want to make a note of is that H is never going to be negative. So H will never be negative. In our case, that negative will go up with that 3. So now the tangent of theta, we know tan is O over A, TOA. Okay, so that negative 3 will be on the bottom, 4 will be on top. And we are done. Now this final one here on the front side, same approach. They give us sine and cosine again. This time there's a negative on both of them. We know that negative can't go with the hypotenuse, so it has to go with the O. It has to go with the A. Now from here, we are asked to find both the tangent of theta and the secant of theta. So once again, tangent of theta, you guys know that one, TOA, O over A. So to find this one, O is negative square root of 5 over A is negative 2 square root of 5. Now from here, I'll grab that blue pen. The negatives are going to cancel. Square root of 5 and square root of 5 cancel out. And we're actually left, so if all that cancels on top, just with a 1 on top over 2. So 1/2, that is what we get. Now our next one is secant. So secant of theta, if you have trouble, keep this list handy. If we go up here, remember secant is the reciprocal of cosine. So if it's the reciprocal of cosine, you can just flip this, okay? So we'll get negative with the 5 out front, 2 square root of 5. Now from here, we cannot be done. We have to rationalize that denominator. So square root of 5 is on the bottom. We can still multiply that by square root of 5 over square root of 5. Now at this point, it gets a little interesting. On top, we're going to have, well, that negative keeps coming, then negative 5 square root of 5 all over. Now on the bottom, square root of 5 times square root of 5 becomes 5. And then you have to multiply that by 2, so we get a 10. Now from here, the 5 and the 10 reduce. And my final answer here, just negative square root of 5 over 2. Right there. That is my final answer. So that one was a little bit difficult, but that is our final answer. So the next thing I want you to do, as we go to the back here, what do we do if instead of the sine and cosine, we're given a specific point? Okay, so we can identify this point with enough information. If we think about on the coordinate plane, the first thing we want to do is draw a triangle. And when we draw this triangle, it's always going to be from the origin. And so if we think on the coordinate plane, there's basically 4 different triangles that we could have. We know it's either going to, or it's always going to start at the origin. It could either go up here, or it could go in any of those 4 quadrants. So if we think about it, kind of like a bow tie. If you ever have trouble coming up with it, just draw this bow tie. Now the key thing to think about is we have our 4 quadrants. Quadrant 1 is when they're both positive. Quadrant 2, it goes around counterclockwise. I'm guessing you've seen this before. Quadrant 3 is there. Quadrant 4 is to the bottom right. So up here we have x and y are positive. Here x is negative, y is positive. Here x and y are negative. And here x is positive, y is negative. So depending on which of these quadrants we're in will determine which of these 4 triangles we're using. Now, for this point, it says 3, -4, find the exact value of sine, cosine, and tangent. So the first thing we're going to do is draw our picture, and let's identify if it's 3, -4, that's right 3 down 4. That will be in quadrant 4. So if we're drawing a picture, we want to think about it like this. Okay, so now if I go over 3, down 4. So 1, 2, 3, 1, 2, 3, 4. So as I connect that, so if I was going to label this now, the label here is 3, the label here is -4. That's how you can have a negative on one of the sides. It's in the negative direction. Now, I don't yet know what this side is. This is my hypotenuse. Theta is always going to be up here by the origin. So this side, excuse me, is our O. Let me put that up here. And this side is my adjacent side. Let me grab a drink quick. So, as we look to find that missing side here, we can use Pythagorean theorem. So a squared plus b squared equals c squared. So 3 squared plus -4 squared. All that will equal c squared. Now at this point, we know that 3 squared is 9. -4 squared is 16. Becomes positive, right? So we get 25 equals c squared. And from here, take the square root of both of those, and we get c to be 5. Remember, the hypotenuse is always going to be a positive distance. Okay, so we've got that 5 now, and all we have to do now is write what is sine, cosine, and tangent. So sine of theta, cosine of theta, tangent of theta. We can simply use SOHCAHTOA. So sine is opposite over hypotenuse, or so. Cosine is ca, or adjacent over hypotenuse. And tangent is toa, or opposite over adjacent. So when we fill that in, and right here, these are our 3 answers. And we are done. Now we've got one final example. This time they don't give us a point, but they give us some information. They tell us what sine is, and they also tell us what quadrant theta is in. Okay, so quadrant, keep in mind, that's not quadrant 11, that's quadrant 2. It's in Roman numerals, right? Quadrant 2. So Q2 is up here, quadrant 2. So you might also see quadrant 3, like quadrant 3, you might see like this. Quadrant 4 could be IV, just keep in mind. If you see that, that's what that means, quadrant 4. Okay, so as we look to draw this now, we know that theta is in quadrant 2. So as I draw my triangle, we know that it is somewhere up here, and that theta is right there. Okay, not the best theta, but it'll work. Now, since this is sine of theta, sine we know is O over H. So the opposite is 12. The hypotenuse is 13. I don't know what A is, but I can solve it. So once again, the first thing we needed to do was draw the triangle. We've got that figured out now. So now we can go ahead and solve. So once again, we're going to solve using a squared plus b squared equals c squared. The only difference is this time c is 13. So 12 squared plus b squared equals 13 squared. 144 plus b squared equals 169. We subtract that 144, and we're going to have b squared equals 25. Hopefully you guys know, just like we did up here, square root of 25 is still 5. So we get b to be 5. So that adjacent side is the 5. Now, the only thing we have to be careful about here, we need to watch for invisible negatives. Okay? I'll explain what that means in just a second. So, since our picture is in quadrant 2, that means the x value has to be negative. If you look here, it was left from 0, 0, it was left 5. So even though we found b to be 5, that actually is going to be negative 5. Now when we find our tangent, we want to put the tangent of theta, just like before, it's TOA, so opposite over adjacent. So we get 12 over negative 5, and we are done. Don't forget your negatives, be careful. The reason we need to worry about those is soon we're going to learn about something called our unit circle, and everything is kind of oriented in the same way around the origin. We'll get into that more later as you guys come back in person, but hope you guys have a great day. If you have any questions, please reach out, let me know. And then today there is an It's Learning assignment. It's pretty short, but go ahead, make sure we get that done and submitted. Have a great day, and I will see you guys soon. Bye.